Welcome to the Evolution 2.0 podcast, where we explore the intersection of art, technology, business, biology, and spirituality. Here you'll discover new trends in evolution that are changing the way we think about everything. This is your host, Perry Marshall, author of Evolution 2.0, 80/20 Sales and Marketing, and Guides to Ethernet, Google, and Facebook. I'm founder of the Evolution 2.0 Prize, a quest for the missing link between earth science, the information age, and life itself. Let's join the conversation now.
Hi, this is Kyler on the Evolution 2.0 podcast with Perry Marshall. You were recently on the Unbelievable podcast.
Yes.
Tell me about that.
So Unbelievable is a very popular podcast and radio show broadcast from London. And it features dialogue and point-counterpoint between a Christian and a non-Christian on all kinds of topics every week. And they have many tens of thousands of listeners. It's very popular. And I was on the Unbelievable show with my prize judge, Denis from Oxford, eminent scientist, and another eminent scientist, Lee Cronin, who is a chemist in Glasgow, Scotland. And world-class chemist, has one of the biggest chemistry labs in academia, and Lee is an origin of life researcher. And so we were on the show to discuss, where did life come from? What's the relevance of the Evolution Prize? What are we looking for? And so this was a very interesting show. Well, in the middle of the show, the host, Justin Brierley, threw down a gauntlet. And he said to Lee Cronin, so Lee, James Tour has been very critical of origin of life research and saying that they're painting too rosy of a picture. What do you think about that? And so I'm going to play that clip for you first, and then we're going to come back and discuss it.
Awesome.
Right.
I think that life might have got going on Mars, a little bit of the chemistry search.
Okay.
And then it kicked out that chemistry.
Right.
And because Earth has got a bigger gravitational pull, Mars was in the habitable zone earlier, so we got cooking. So it did the pre-course for you, and chucked it on Earth where it made the main menu.
Okay, that's an interesting theory.
Maybe.
What do you reckon about that, Perry? Do you think? Do you feel in any way like there's a chance we could find life elsewhere, and what would that have to say to your search for the origin of life yourself, Perry?
I don't have a strong opinion about it. I'm probably roughly similar to Denis on this and Lee. Hey, if this happens to be the case, well, that's very, very interesting. On the other hand, there's a book probably 15 or 20 years old called Where Is Everybody? And it's a book about, where are all these aliens that should be so abundantly likely to occur? So I don't have a real strong.
I had probably getting on for 10 years ago now, Paul Davies on my show, it was around a particular anniversary of the search for extraterrestrial intelligence, and he'd written a book called The Eerie Silence, and I remember him saying effectively, well, life is. He said life is at one level incredibly improbable, such that either it's only probably developed once here on Earth, or there's some other principle at work whereby if it can arise, it will arise, which kind of sounds like your principle at some level, Lee. But he was also very critical of the typical sort of happy chance coincidence kind of theories. He said that's just not really a viable option. We're going to go to a break just shortly, but here's a name, and I don't know if any of you have come across this. Probably Perry, you might want to speak to this. Someone who people keep saying I should get on my show to talk about this issue is James Tour, who I believe is a US professor of nanotechnology. And from what I've heard, Lee has put his head in his hands, which I guess suggests the way he feels about this name. I'm coming to this as a layperson, but I've heard people saying Jim Tour, he's your man, because he says he knows his stuff, and he says it just isn't going to happen in a naturalistic fashion. There has to be some kind of design going on, an input of information right at the beginning. All right, before we get to Lee, who looks very who has had an interesting reaction to that name, Perry, what's your position on Jim Tour and what he's saying in this debate?
Well, if you want to replicate the way a cell does, you have to have symbolic code that stores information about how the organism is supposed to be put together. And that's completely different than RNA strands making copies of each other, which is kind of like crystals forming. And so I gotta say, there's a lot of dishonesty in the origin of life field, and James Tour is saying what he thinks, and I at least salute him for doing that. And I'd be interested in hear what Lee has to say about the specifics. In fact, maybe Lee and James could have a debate on this show.
Maybe they could.
Fantastic.
Maybe they could. But we're going to go to a break for now, and then we'll hear what Lee has to say about James Tour. It's been such an interesting discussion today. Can chemistry crack the mystery of the origin of life? My guests Lee Cronin, Denis Noble, and Perry Marshall have been with me. Lee, before we continue the conversation, where can people go and find out more about your fascinating work?
Just go to croninlab.com.
croninlab.com.
Yeah, just
Great.
one word, and there's all the papers and news there and the way to contact me.
Fantastic. I managed to watch a little sort of mini documentary, I think it's a couple of years old, about you and your family and your search for the origin of life. One bit that amused me was you were all sat around the dinner table or doing some activity with your little kids. They're probably a bit older now, but and you asked one of them, where did humans come from? And one of them said, God. And then the other, I think younger one, piped up, no, don't be silly, God doesn't exist. And I thought, I wonder where that's come from. But I mean, this takes us neatly to the question of design. The design hypothesis, you've said, well, look, we need to look at it at least. We can't dismiss it out of hand necessarily.
Sure.
And it sounds like people like James Tour, who, as I say, isn't here to defend himself, but as far as I understand it, he kind of fits with a kind of intelligent design view that actually you cannot get a naturalistic explanation that does justice to the origin of life. There's too much improbability, too much complexity. You've got to have a kind of input of information right at the beginning. What's your overall reaction to him and to those kinds of theories?
I'll give you one word: nonsense.
Well, that was a pretty interesting clip.
Yes, and the listeners thought it was pretty interesting too. And what happened next was a whole bunch of listeners wrote in and said, Justin, you've got to get James Tour and Lee Cronin together on your show. So Justin pulled some screens and he made that happen. So that show has now been recorded and broadcast. And next, I want you to hear what happened when James Tour and Lee Cronin went head-to-head on The Unbelievable Show.
Well, today on the show, it's round 2 debating the origins of life. James Tour and Lee Cronin join me on the show today. Now, in November last year, I brought you an unbelievable discussion on how on earth did life begin, featuring Lee Cronin, whose Glasgow lab is working to crack the mystery of the origins of life. Now, Lee believes his research group is on the cusp of giving a purely natural explanation for how inorganic chemicals turned themselves into the first self-replicating form of life. Now, following that discussion, I was inundated with requests to bring one person on opposite Lee to make the case for why current research into origins of life is nowhere near to overcoming the complexity and odds involved in getting life going. Now, his name is James Tour, though he goes by Jim. He's Professor of Materials Science and Nanoengineering at Rice University in Houston, and Jim is regarded as one of the leading voices in the world responding to origins of life research. So today is a rather unique show, bringing together two people who are leaders in their field in this fascinating and much disputed area of science. So Jim and Lee, welcome along to the show. It's great to have you both with me today. Perhaps we'll come to you first of all, Jim, as someone I've long wanted to have on the show. Really pleased that in one way or another, the last discussion on this sort of facilitated you eventually making the time to come on the show. I'm really pleased about that. Tell us firstly, before we get into the subject today, a little of your scientific background and the sorts of work that you undertake in the laboratory when it comes to nanotechnology.
Well, I'm trained as a synthetic organic chemist and worked for the last 30 years, moving that more away from natural products and more toward material science and nanoengineering, trying to build systems that can function and operate as machines where we use, for example, a light input and have those machines operate. More recently, we're having them drill into cells and do cancer treatment in that way. Plus, we have a large program in graphene and carbon materials, everything from medicine to aircraft wings to just making new materials possible, things that had never been made before. So we span across several different areas.
You are a Christian in terms of your personal faith commitments. Does that make any difference to the way you do your science in the laboratory and the way you approach issues, for instance, around origin of life research?
Well, actually, I don't work in the area of origin of life. I just started reading about origin of life about four years ago and trying to understand where people were coming from. I was studying evolution, and that brought me to origin of life. And then as I started to look at the organic chemistry that's been done in the origin of life, I came to the conclusion that we're clueless, that humankind is clueless on where life began. And as I started to study the work, I felt that so much was being said that was untrue, that was just hyped up, and not only are young students mystified and bewildered by this, but professors themselves don't know, and professors themselves are lost in these issues. They think that all of this has been figured out, that carbohydrates came from the foremost reaction and life built up from an RNA world, because they've never studied it. They were just like me. I had never studied it, and I took these things for granted. I trusted people, and I see that I shouldn't have trusted them, because when I looked at the data, it wasn't there. And I wrote one article on the topic, calling people out on it, and then that snowballed from there. I started being invited to give talks on this, and it's interesting that none of my colleagues privately would disagree with me. They'd all agree with me that they didn't know. But I don't personally work in the area of origin of life. Now, you asked whether I'm a Christian. Not only am I Christian, but I love Jesus tremendously. He is the best. He is everything to me. I am much more than just a Christian in name. I come from a Jewish background, so when I came to the Lord at the age of 18, and I came to see that Jesus was the Messiah, it was a huge change. For me, it is not just something in name. So how you asked, how does it affect my research? But it affects my research in the way I interact with people. I'm held to a higher standard because of Jesus Christ. I ask God to give me insight, to give me wisdom, to give me creativity in my work. The scriptures are filled with people like Bezalel, where God specifically filled them with the Holy Spirit and gave them wisdom. For example, in Exodus chapter 31, across many different disciplines. And so in that sense, I pray and I seek the Lord. But still, that doesn't mean that I have to neglect the bookwork. I mean, I have to study the work, and for me, it's just asking God for wisdom is what it is.
Sure. Let's turn to you now, Lee. So welcome back. We didn't scare you off too much in the last show, I'm glad to say. And it's great to have you back on the programme. Just be interested to know what sort of reaction you got from being on the show, whether you kind of heard back from any of your colleagues in the area or others to the discussion that we had last time on the origins of life.
Actually, I got some quite unexpected feedback from some of your listeners. Actually, some scientists who are Christians, and they actually, because I come across as quite a forceful character, they were pleasantly surprised by the consideration I gave their religious point of view. Not in that, I mean, I'm an atheist, but I don't think that is a excuse for me to demur on someone's ideas or beliefs, right? As I talked about, I don't believe that belief and falsifiability in science actually interact. Belief, where falsifiability ends, belief begins. And so I kind of do react against people like Richard Dawkins, who kind of assert that religious people are somehow not smart enough.
Okay.
Because that's just a lie and offensive. What I would like to say, though, is I think what is important is to really, as Jim was saying, is do the book work. But I do think it's not just about a point of view. I think whether you have if you have a point of view where there was a creator, obviously, if you believe in God, you believe in God as a creator of some description, and that's however God affects the universe. Well, I think there is a unity and there is a mystery in terms of how was the universe set up. I don't think there's anything magical in the physical universe at all. Actually, I think it can all be described by science. And that Jim might disagree, and we can talk about that. But I think it's really important to have the frame of the discussion respectfully, and also on the basis of what we can interrogate using the rules of science.
Yeah.
Because I think there is an interesting problem about the history of origin of life. But I'll let you bring us in.
And I was going to say, Jim, I think you're keen to stress yourself that you're at the end of the day interested in the evidence, just like Lee is, aren't you?
Oh, absolutely. And this is where I think I was mischaracterized by you, Justin, in your last broadcast when you were on with Lee and with Denis Noble. So for me, I have never brought in God into any of my arguments on origin of life. I've never done that. I've sent all the 4 papers that I've written on this topic. I sent them to Lee, and he can attest that I don't mention God in this. I use purely naturalistic explanations for what I have to say about the evidence. I am just merely critiquing the evidence of others. I never bring God into this. If you look at any of my scientific papers, I don't bring God into this. And so I'm quite able to speak like that, and that's all I wanted to address in this in this discussion, was to only address it in that way. I only just mentioned God and Jesus Christ because you asked me the question. Sure.
And I mean, we'll maybe come back to this towards the end of the show as well. But obviously, the parts of the world where these issues are being contested sometimes involve the intelligent design community. And I know you have spoken on, at conferences run by the Discovery Institute and so on. So, and obviously some scientists see them as somehow having a God agenda. What's your view? For you, could it be that if the naturalistic explanations in Origins of Life, and we'll come to them in a moment, aren't working, that one option is, well, maybe there is a designer, some kind of cosmic designer that's at work here?
Well, let me just make a distinction, and this gets back to addressing why I even am on your show today. It's because I want to correct things that were said about me in your last program when I wasn't there. You said at 54 minutes into your talk, you said James Tour, quote, fits with the intelligent design view. You cannot get a naturalistic explanation that does justice to the origin of life. There's too much improbability, too much complexity, unquote. So that's what you were suggesting that I speak on. And that's just not true. And then Lee's response to that was, quote, I'll give you one word, nonsense, unquote.
Okay.
So you set up this straw man of who Jim Tour is, and then Lee came in and kicked the thing down.
Well,
so
I should just come in there and say, I mean, I think we can discuss about, because you do design what you call nano machines, but they're not machines, and we can talk about narrative and design and what that means. And I think we can do that in a very productive way. And I think, I mean, Justin can talk about his mischaracterization or not, but what I was saying is actually the whole idea that intelligent design has any scientific basis is, for me, the answer is not just nonsense, but demonstrable nonsense. And we can discuss the reasons for that. And I think actually from some of the things that you're discussing, I think we're going to agree a lot on that. And it's quite important, I think, from both our point of views, whether you're religious or not, to have a fair and well-grounded debate. And so we can actually make progress.
Well,
I think, in the field.
And I will hold my hands up wholeheartedly, Jim, if any misrepresentation took place. I was speaking off the cuff, and in a sense, that's exactly why I've got you on the show today, so that you can speak for yourself, right, and make and be clear on what you actually do believe, what you are saying about the research. Before we come to that, could you, for the sake of people who maybe can't remember or didn't catch the first time round, Lee, just very briefly, what your research essentially boils down to and is saying about how life got going on Earth?
So I'm an inorganic chemist, and I'm always been faced with the complexity of crazy kind of reactions and understanding what goes on in a reaction vessel in an experiment. And what I was trying to convey in the last discussion is that although the presence of life on Earth seems like it's a miracle of complexity, what I was trying to convey is I think that we have begun to develop a pathway to understanding how that, not only how that complexity arises, but creating that process in the laboratory, not identically, because not about identically kind of trying to check a historical account, so we have a time machine, but showing the laws of what law of the universe allows life to come into being, and to explain that that's just a gradual process. And also, why I think we might vigorously agree, but we'll wait until Jim and I discuss, to express some frustration in the origin of life community, where people have set themselves up for an improbable discussion to say, if this molecule was present at this concentration on this day, and then this would happen, and scientists want to have mechanistic control. And I would argue it's not, people aren't being disingenuous, they're just using a narrative to explain their experiments. And this actually is happening in nanotechnology. People building nanomachines? No, they're not. They're looking at the formation of architectures from the top down and bottom up. Same in the origin of life debate. Lots of people are going top down. I think this happens. I imprint my narrative on it. Rather than going bottom up, how do we actually see what features of the universe allow complexity to develop such that evolution can get going? And I think what I can do today is carry on the discussion about how those experiments can be used productively to kind of have a new debate, because it's important for the young scientists coming into this that they don't get sucked in by a narrative, that we ask the question in a new way. And I think, again, I don't want to speak for Jim, but I think he and I might agree on there is a need for displacing a narrative with more interesting and unifying questions.
Let me come back to you first then, Jim. It might be helpful for you to sketch out how you have understood Lee's research and what he seems to be saying in it. And equally use this time, feel free to obviously address any other issues that came up in that first recording we did, where you feel either the research or yourself were not being represented adequately.
Yeah. Okay. So let me just address that. I think that I was not being represented adequately by you, Justin, and I just corrected that. But also by Lee. Lee's said of me, quote, number one, he's just trying to provoke people to see how they will react, unquote. And that's just not true. That's absolutely not true. I think now that I've sent him my papers and he's read them, he might say, yeah, I'm putting forth arguments. I'm not just trying to elicit a reaction from people. So, but I really want to say also, I respect Lee for coming on here. He is the first origin of life scientist willing to speak to me in a public forum. And others have spoken to me in private, but he's the first one willing to speak to me in a public forum. And I think that that's telling in and of itself that the community is avoiding me, in the sense that they'll avoid a discussion with me on the very topics in which they are publishing. And it's not that I haven't tried to speak with them. So first of all, let me thank Lee for being willing to stand up and do this. And I'd like to just go through and go through step by step the things that I heard in the last program and address these. Because Lee spoke for about 45 minutes in the last program. He said a number of things, and I tried to track with him. I really did want to understand. I tried 4 times to go. I went through 4 times that program 4 times. That's 4 hours I went through this program to try to understand where he's going. And then he kindly sent me 5 papers, which I've gone through to try to understand where he is on the origin of life and what he's trying to do. And then I'd love to be able to discuss with him the things that he's trying to address and give my critique on it.
Well, let's start just maybe with one of them, let's say. Tell us what you understood to be the basic thesis of Lee, and just this will obviously have to be a sketch, but just generally where you find it problematic ultimately.
Yeah, I find it problematic in that there's an extrapolation from a very small experiment in a laboratory. There's an extrapolation to giving people an idea that we really understand more than we do. And what I appreciate about Lee is that he said he's a scientist and he likes to have discussions where he can, and he says, and I like to have discussions where I can have arguments about evidence, unquote. That's what he said. I'm all for that. So Justin, you then said that you, in GCSE biology, which I had to look up because I didn't know what GCSE is. And I figured, I found out that that's sort of like equivalent to our high school.
Yeah.
You said there was some kind, quote, there was some kind of primordial soup billions of years ago on the surface of the earth, chemicals swimming around, maybe bolts of lightning going off, and somehow something happened and poof, you got your first sort of very simple cell or something swimming around in the ocean. And then you asked Lee, am I right? And Lee said, you asked Lee, you said, is this view essentially correct or fundamentally wrong, unquote. And Lee said, you're not wrong. Your GCSE chemistry is not too bad at all. And I'm like, what? Where is the evidence for this? Here is a man who just said that he likes to discuss evidence. You tell him that there's a primordial soup and somehow things sort of got going and that's how life formed. And you asked Lee, is that right? And Lee, being the authority on origin of life, says, you're not wrong. Quote, you're not wrong. Your GCS chemistry is not too bad at all, unquote. And I'm like, this is the type of extrapolation that I'm talking about from one of the premier people in the world in origin of life. And I'm saying, okay, you got evidence for me? Help me. Give me the evidence for that, Lee. Give me the evidence. I'd love to have it.
There's plenty of it. So, okay, well, let's just take a step back. So it's clear that chemicals on Earth before life were simpler because there was no machinery to make chemicals. The debate that I think you're digging into a debate that origin of life people have, that I was giving Justin a GCSE, not a degree in chemistry, and that I don't care whether the atmosphere is oxidizing or reducing. We simply don't know. We can look at the fossil record, the geological record, and so on and so forth, and ask those questions. However, from meteorites that we have from the solar system, from where the birth of the solar system is, we know what type of chemicals are present. And basically, when you look at, say, Murchison or other meteorites, carbonaceous chondrites, we find very simple organic molecules with some nitrogen and oxygen, some carbon, some hydrogen, maybe a bit of sulfur, the elements that we'd expect we find on Earth, very simple versions. So all I was saying was that. Now, I think that, Jim, you've got to be careful here because you are trying to build a narrative. And building narratives in what I'm not interested in. His GCSE chemistry was fine. GCSE high school chemistry. Was there simple chemistry on Earth? Was there some energy on Earth? All those things, to the best of our knowledge, yes, there was energy. There was a lot of things going on. There's a great deal of evidence for the late heavy bombardment and all that stuff. But if you want concrete evidence, you can get meteors that are 4.7 billion years old, which have simple chemistry on them. And I think the thing that you're maybe creating a straw man here, because I think we basically agree that in the past, chemistry looks to have been simpler. We have seen no evidence of complex chemistry emerging before life on Earth. And complex, I would say, large molecules that you can hold in your hand, maybe that you can manufacture in your lab. And there is good evidence for that. There's plenty of peer-reviewed publications which talk about that information. Now, it doesn't suggest there is not evidence for what the lifetime is of erasure and the half-life of that complexity. However, we are beginning through very radioactive carbon dating, heavy atom carbon dating, and looking at the entropy of material, the disorder of the material, to kind of piece together if there was something complex there. But that is a very, very hard problem. So I disagree with you that Justin's chemistry is just fine. I don't know what the precise nature of that is, and maybe what you're getting at is some origin of life people says, look, it was reducing, then it was oxidizing, then there was phosphorus, and then there was sugar, and there was RNA. No, I would agree with you, there is no evidence about what sequence of small molecules were there, but was there a super simple molecules there on Earth at the beginning? Yes. And we can trace it back to the Big Bang, where we have proof that there was a Big Bang. And then we have stars forming, and those stars explode. And when those stars explode, they produce elements in their elemental form. And when they accrete on a planet, they then gain complexity.
Okay. Yes. Feel free to respond there, Jim.
Okay. So Lee, that's not what you said, and that's not what you put forward. I agree. We have small molecules that might be oxidizing.
I did not say anything else. That's exactly what I said. Justin said, was there a prebiotic soup? And I said, yes, the evidence says so.
No, and Justin said, then cells came forth, life came forth from that. All right. So
that is indeed
you were a little bit loose on that. Let's get more specific. But what I'm saying is, you are the authority here. When you tell him, he asked you specifically, he says there was a primordial soup, and life came forth, and your very simple cells came forth from this. We have no evidence how this thing happened. Lots of small molecules. A cell's pretty complex.
We don't know how it happened, but the evidence on Earth says in the fossil record that life appeared very, very quickly, after the late heavy bombardment. So that is evidence in the fossil record that is not disputable. I think we both agree, planet Earth formed, rocks, simple chemistry, no life. Right? We don't know all the details of that, but then within a few 100 million years, there's evidence in the fossil record that life formed, simple cellular life. Those two facts are not, as far as I know, disputed by
those are not contestable. How we got from the point A to point B?
Absolutely, but I did not say we knew.
Right. So we're agree. Okay. You and I agree, Lee, that how we got from the simple molecules to life, it happened, but we don't know how. Okay.
Exactly.
So now I'm trying to understand what you were teaching us here. You said there's nothing magical about the emergence of life. It's really simple. That's what you said. And so I looked up, because I'm not a biologist. So I looked up what are the characteristics of life. So I just Googled it. What are the characteristics of life? This is responsive to the environment, growth and change, ability to reproduce, have a metabolism and breathe, maintain homeostasis, which I can give you a definition for that if you need it. Being made of cells and passing traits on to offspring. Now, we may or may not agree on that definition. That is a textbook definition of the characteristics of life. And you said that if you have information, you have life. You said, quote, universes without life are universes without information. So indeed. I just want to understand you. I'm asking you a question. Information itself is not life. Would you agree with that? Life has information, but information itself is not life. I can have a piece of paper and write on that piece of paper. That piece of paper bears information, but that piece of paper does not have life.
No. So that information on the paper is as much alive as you are, actually. But let me frame that properly, because I think, again, we're going to end about, I think most of our argument today may be semantic. If you did not exist, you would not be able to write on that piece of paper. So if someone brings to me a piece of paper with words on it, that just tells me that's evidence of life somewhere. The problem we have with life and the origin of life and definitions, we don't actually know what life is. And that's a problem. So that's why I made that very well thought out statement that universes without life that can't have information, because there's no syntactic information. There's no encoder and no decoder. Universes without life, of course, have the laws of physics in them and the laws of chemistry. But I'm really interested in that transition to a agency or a decision-making entity, like how many chemicals do you need in a pot? And we've begun to see in my laboratory how that can be steered. And I think that's counter all the debate, counter what you're saying is possible, counter what the Origin Life says is possible, but we're just doing experiments to ask those questions. But so I would say the piece of paper you write on isn't alive, it's not metabolizing, not in your definition, but you put that there. Therefore, if I found that piece of paper on another planet and I was able to discount that from background entropy, I would know that a living thing had put it there. And that's all I can do right now. I know so little about what life is that I'm able to understand. I think I kind of view myself a bit like before Isaac Newton wrote down how gravity worked. I know that gravity exists, I can see it, but I don't yet have the equation for it. And isn't it interesting that, it took Newton and then Einstein to quantify the law of gravity, and then obviously people could then apply that everywhere in the universe. But we knew it existed, and I'm kind of excited because we're in this like pre-quantum mechanics world for biology, pre-understanding the equations, the physical laws that give rise to biology. But confident I am that we'll find them, and I can give you many reasons for that, but confidence is nothing without evidence. And what we have to discuss today is the evidence trail that is leading me down this track. Obviously, it's not finished yet. I haven't made life in my lab yet. I will. The argument will be that life that I made in the lab, did it just come from me? And where did I come from? And so what we have to work really hard to do is not obsess about the origin of life, but how can we create complex chemistry from simple chemistry? And what are the laws that turn that complex chemistry? And one comment I'll say is like in nanomachines, we're never ever going to make nanomachines deterministically. We have to evolve them. The cell is a good example of that. And even today, with all this work in nanotechnology, Jim, that you work in, there is not one functioning nanomachine in our technology made from the chemist up. It's all from the electrical engineer down.
Right. So Lee said that we may come down to a matter of semantics in our discussion. I don't disagree with that. Let me just say also up front, the reason I have never supported intelligent design, although I'm sympathetic to the arguments, is the first line on my website under the evolution creation page. I don't support intelligent design because I have no tool to measure it. I have not a tool to measure that something has been intelligently designed. So I hold my colleagues to the same tools and standards that I'm going to have to hold myself. That's why I don't support it, because I have not a tool to measure it. I'm not against it. I just have not a tool to measure it. Secondly, I've never said that this cannot happen by a naturalistic explanation. In fact, I've gone on to say is I have no idea what we're going to discover in 50 years, 100 years, 300 years from now. If 150 years ago you asked somebody where is information stored in a cell, they would have said, I have no idea. It must be God. No, well, we understand that the information is stored in the cell and the DNA. So we learn things with time, and that's what I'm saying. As of now, there's many things that we just don't understand. So to project as if we understand them, and to project as if we understand them, whether we're speaking about high school students or professors, is wrong. We just have to say, this is an open discussion. We can't address this. Now, as far as information that Lee was talking about, that life has information. And yes, if you find a piece of paper written on it, you know that life was there. I agree. But life has information, life has matter. We have to deal with both of these. We have to deal with information and we have to deal with matter. Matter is a huge, huge problem. 99% of what I talk about in my papers is the matter. I might have a paragraph on information. Lee says, my biggest problem is I don't understand information. That's what he said in the last thing. And I will confess, I am not I am not an aficionado of informatics. That I am not. You had Perry Marshall on there. He is. I don't deal with information. Most of my argument has to do with the matter. In order to have life, you have to have the matter around life. It is not merely information. And so Lee has said biology, all that biology is chemistry with history. And I look at this and I'm thinking, well, biology is really complex. Biology has chemistry with history, but it is not chemistry with history. It is enormously more than just chemistry with history. It's extremely complex. And what I feel that Lee is doing is that he is putting out a definition of life that would allow him to try to get at, say, this Evolution 2.0 prize. But it's not a definition of life that any biologist would look at this and say that this is indeed life. Now, again, maybe I'm wrong, and Lee can correct me on this, but biology is the science of life and living organisms. An organism is a living entity consisting of one cell, for example, bacteria, or several cells, for example, animals, plant, fungi. That's what biology is. And that definition that I just said is something that, again, that I Googled. I said, what is the definition here? You've got to have a cell in order to have life. You just want to say that I have a recursive information system. That itself is not life.
And just before Lee comes in, from what I understood, and again, Lee can correct this, but what Lee has achieved in his lab in terms of what he's witnessed in terms of these replicating, I think it's salt molybdenum crystals or whatever. For you, what he sees as the beginnings of an explanation of how life arose and how a complex system could ultimately emerge. You believe simply are nowhere near, presumably, what actually constitutes life, and therefore Lee shouldn't be talking about it in terms of being some sort of approach to the origin of life.
Well, I know Lee is bursting to comment, but you just asked me a question, so let me answer that question. I wanted so much to understand from Lee what he was talking about. I listened very carefully on the last broadcast, and he talked about salad dressing and life. He said life formed in bubbles, and these bubbles are like salad dressing. They get stuck, something gets stuck, and then all of a sudden he starts to talk about flipping coins. I was trying to track with him. And then when he said there's a paper on this, and he was kind enough to send me this paper, I, with great enthusiasm, went to that paper with great enthusiasm because I wanted to see. And, I feel like I was told this is going to be the greatest show on earth. And I went in there and there was an old poodle standing on his hind legs. I mean, there was nothing. This is just an autocatalytic reaction. You're forming some clusters, and other clusters can use those as templates to form around them. Autocatalytic reactions have been around a long time in chemistry, for over 100 years. Oswald came up with these over 100 years ago. I don't see how that is giving you information of life. The day his student walks in that laboratory, by walking into that laboratory, he's influenced that experiment. By choosing a chemical off the shelf, he's influenced that experiment. And then all he set up was an autocatalytic reaction. I think that there's nothing there. There's nothing there that points me toward anything of life that any biologist looking toward what is defined as life, not by Lee's definition, but by anyone else's definition, where you have to have, example, one cell, like a bacterium, anything like that, anything close. It's not even close to that.
Okay.
And so I think it's been totally overblown.
Okay. Lee, strong criticisms there then. This is your chance to obviously defend yourself.
Totally unsubstantiated. It's like, look, I really respect Jim. He's making a narrative, as he did in the document sending. I didn't really expect him to kind of be so, I would say, I don't know. Anyway, look, let me address the first point. The right stuff is not enough, right? If I take a cell and grind it into atoms, I get chemicals out. So, of course, information in the cell is how you get biology. The thing that I am perhaps a bit more humble than Jim thinks he knows what biology is. Well, I don't. That's why I'm doing experiments. So biology isn't necessarily defined by a cell. Biology isn't necessarily defined by that. All I know is that if I take a cell and I grind it up, I get atoms out. So reductionistically, I put in my atom grinder. Now, Jim is choosing to not understand my argument because I now know he's making a narrative. The people make narratives from an ideological point of view. I'm not going to go there with the ideology. I'm just going to give you the evidence, the experiments, and then the listeners and the viewers can judge. What I showed to Jim was, he's right, that autocatalysis has been around for hundreds of years. So what Jim was talking about is the way that basically things can self-promote, but they have no information in them. And he talked about a thing called Ostwald ripening, which the listeners that are listening might want to look that up. And Ostwald ripening is a macroscopic technique where there's no information. The paper I showed Jim, and actually is on the archive, shows that molecular information, that is a template like that DNA does with itself, can basically template at the molecular level one structure that's impossible to form without that template. So it's almost like you're able to put a template into an archway, like a Roman archway and put in a key, and then on that template you can build another one, and there's a hierarchy of templates. And what we've shown is you can make what's called an autocatalytic set. And the word set is really important. There is no example outside of biology of a catalyst that makes a catalyst that makes a catalyst that makes a catalyst, and they work together. Maybe Jim is jealous because he wants to do it his nano stuff, but no one's managed to engineer it. We managed to discover one by scratch by searching. And yes, I would agree with Jim. We went and got pure molybdate off the shelf. The human being did that deterministically. And we have to account honestly for the information that we put into the material, into the experiment. And that's a valid comment. It's not a criticism. It's an assumption that you have to make. Now, I think that Jim is saying it's impossible to know what gives rise to biology because it's complicated. And I'm just saying that's a fairly poor argument. And we should say, let's agree on our assumptions. We both assume that chemistry at the origin of life was simpler than it was today. That's an assumption that can be tested. I'm happy to write down all my assumptions and test them at every stage. That's what a good scientist does. First assumption, no life. Second assumption, simple chemistry. Third assumption, a little bit of time. Fourth assumption, bit of energy. And then fifth assumption, some kind of selection in the environment, some kind of persistence. What is that? And I try to help the listener understand, and I was aware that not everyone is a professor of nanoscience, so I put it in terms that I think the listener could get some kind of analogy, metaphor out of. And Jim is kind of lambasting me for not having the correct term. He's already admitted he's not going to understand the mathematics if I write it down. So the point is that we are talking about only one point of biology on Earth. We don't know what biology is. So it's ridiculous to kind of say, I'm going to make biology. I'm actually, if anything, an inorganic biologist or maybe an astrobiologist. I have made, to counter Jim's argument, a detection system that's going to allow us to distinguish alien life from non-alien life on other worlds and also use that in the laboratory. And I'll give Jim a working assay for biology or not, which he can try and attack, which is if I have a system, a magic black box, and let's say in that black box, there could be a living cell, or there could be some random chemistry. I'm not allowed to know what. The only way I can tell when I get stuff out of that box is by looking at the complexity of the molecule. And we've done some good mathematics and some good arguments. And I've sent Jim that other paper, but maybe he's going to tell me that's all nonsense as well, that explains when you use a pair of scissors, if you cut up the molecules, whether that has been generated in a genetic system or an informational system, because genetics is a strong word, or not. So we have developed a test for finding chemistry that's becoming more complex. We're then developing a model to go and search for that. And now we're then instantiating that in the lab with good experimental assumptions. And we're going to go back and say, is that valid? Is that valid? What we're not doing, which I hope Jim will give us some credit for, is saying it's RNA, it's sugars, it's this, it's this, it's this. We're saying, no, we have no idea what the pathway to life was, but we know that living systems create complex artifacts, be them molecules, proteins, ribosomes, or the works of Shakespeare. So let's use those as a encoding for a experiment. And that's the falsifiable thing that we're doing, because the origin of life isn't even a falsifiable question. I can't even go back. No. I don't know what happened. I never will. In fact, I actually don't care what happened at the origin of life. What I care about is if I can create a life form in the lab now with minimal interaction with it, or even better, can I see a life form naturally emerging on another planet as an observer? That would be a dream. Okay,
that would, wouldn't it? Okay, plenty to respond to there. I'll let you go for it, Jim.
Okay, so I think this is where it's going. I think Lee is becoming a lot more practical right now. So he says that the reason he was saying things the way he was in the last broadcast because he was lowering it to the explanation of the common person.
Not lowering, making it accessible, and not
making it accessible.
Come across, arrogantly.
No.
Okay. So Lee, I did look at your other papers, and I have no problem with those. I think it's great if you can come up with a testing system to see what is life? And I can see why NASA would support such a system, because they're looking for life. And so what are the signs of life? I have no problem with those papers at all. In fact, I know that there's others that are trying to come up with a system to be able to test for intelligence, that there was intelligent design in a system. And I have no problem with that. Let them try to develop a model to look for intelligence. Again, I don't go there. I never use intelligent design as an argument in what I'm doing. I'm just critiquing the science. And the problem is, Lee, that a lot of the times that people hear these things, they hear people from the Origin of Life community say things, and they believe it. And in the Origin of Life community may be saying, well, I was just trying to make that accessible to you, because when I asked them for details on it, the details seem to go away. I think he's got you on.
I can call you out on that when the nanotechnology community say that they've made nano machines, and we say we've made these robots that are going to fix you, and you've done this as well, and I've read some of your papers, and I would argue it's not, the Origin of Life community aren't seeking to be duplicitous. They're simply trying to get people excited about the possibilities. And what I'm trying to do is to take a middle road to say, look, you're in your nano work trying to get people excited about the possibilities for nanotechnology. That's brilliant. Let's make the extrapolation. Maybe we can give that accommodation to the Origin of Life. Sorry to interrupt.
Yeah, but is that a fair criticism that we all, in nanotechnology as well, you're making claims that may seem something in the public, but obviously need more working out in the laboratory? Well,
possibly. I mean, there's a company now started around the nanomachines to drill into these cells to affect the cells, to deliver. We've demonstrated that through these nanomachines we can deliver antibiotics that were formerly outdated, that couldn't get through the bacterial membrane, and now they get in and they kill those bacteria beautifully. So we are showing that they are indeed working, and we've been working on this for all of just a couple of years with these cells, and already we're getting this to work. The problem with Origin of Life community is this is a hard target. So Lee has said all life is, quote, all life is pretty boring if you think about it. Life is a complex chemical system that can persist over time, unquote. And so, Lee, I'm trying to just follow what you say. So in one sentence, you say it's pretty boring, and in the same sentence, you say it's a complex chemical system. And I agree with you. It is a complex chemical system. It entails lots of complex molecules. The Origin of Life community is trying to make a complex molecule and another set of complex molecules. Most of the time they make them racemic anyway. They never deal they rarely deal with the purification problem, and they won't take what they've made and bring it on to the next step. It's all relay synthesis over and over again. It's very complex. It's hard to do, but Lee, as I understand your work, you're not trying to do what many other people are doing. You're not trying to make yet another way to make amino acids, another way to make a nucleotide, another way to try to hook You're not doing that. You're trying to bring us back to the fundamentals of what is life, and can you begin to make something that's lifelike in your lab. And so I appreciate that. I didn't know anything about that, or that's why I've never critiqued your work in any of my writings, because it's new to me, and so that I understand better what you're doing now. So I'm not holding you to account for what these other people have written.
I mean, just before Lee comes back in, just because you obviously have responded to other people in the Origin of Life community, Jim, has your criticism been, you might want to sketch out some examples of people who you think are basically painting a sort of just so picture of how inorganic chemistry went to, a sort of RNA or whatever, and you just think that they're massively simplifying or brushing over the complexity that's involved in that process. I think you had a particular critique of an article that went in Nature. I'm afraid I forget the name of the person who wrote the article and so on. But you as you say, Lee is doing something a bit different to those guys. But you've obviously had quite strong words for others in the community who are trying to make out that there is this naturalistic explanation that we're kind of pretty close to understanding.
Right. Yes. So when they take their little experiment in the lab and they extrapolate it and they bring it to life, it makes the layperson feel that we understand what's going on. That's not the case at all. And it's not just a layperson. Even my faculty colleagues have been confused by these things. And the extrapolations are way overboard. And I think Lee would agree with me a lot on this as I've read his work. Lee's work is very different. I think, now getting back to Lee's work, I think it's oversimplified. I think that he's nowhere near life, but what he's trying to do, and I see this. He said this on the last broadcast. He said what we can't agree on what life is. He says there's no agreement among different people. He says, quote, what I've come up with is forgetting what life is, but looking at what life does, unquote. Quote again, what does life do that is different than, say, a non-living plant? Life makes things, unquote. Again, he says, quote, living systems tend to make stuff. And that is what we call life, and we are looking for it, unquote. And so I see what he's trying to, what Lee is doing. He is trying to step back, because I just read to you a Googled definition of what biology is. Biology says you've got to have a cell there. And Lee is stepping back from his mathematical background. He's stepping back. What I see is to something much more basic. Okay, does life have to be a cell, or can life come from something simpler and then we move on toward this? And so what I feel that he's done, though, in doing this is he projects that what he's doing is he's making life. And now he's telling us, he's saying, yes, it's not life as we would understand it as a cell. It's doing things that life might do. Life tends to make things. Lots of chemistry makes things.
I think that's a very good point. I can be very constructive on, if I may, Justin.
Please do.
I don't know I don't even know if life really exists, right? But that's a really metaphysical discussion we can have another day. What I think is really important is to say, look, if I looked at the asteroid belt, right, and just zoomed in, and I didn't know anything about the laws of gravity, and I was let's just say I was someone who liked asteroids, I'd say, oh man, that's really complicated. And then a physicist says, oh no, actually, I'm just going to write down the equation of gravity, right? It's an inverse square law, 1 over r squared, sum of the masses between them. Boom. The asteroid belt is a really bad place to discover gravity. But if you then go and look at a big gravity well, and there's an asteroid falling into it, suddenly that simpler explanation can then be applied in a more complex context. So I want to just quickly speak to one apparent contradiction. Life is boring, life is boring and life is complicated. What I'm saying is, I think it's boring to try and imagine what the chemistry could be at the origin of life by just taking cells apart, because we've got an existence proof problem. I'd rather zoom out and say, let's just put what we had available, guess, in a can, and see what complex comes out, and say, does that fool our Turing test for life? And then when it does, we then go, okay, we now care, and we're going to go and do that detail mechanism. And we're going to be an organic chemist. We're going to do what all those amazing prebiotic chemists do, but we'll do them in the context of having made an observation that we find interesting, rather than doing a historical narrative-based experiment. So the good news for all the prebiotic chemists, and they're fantastic chemists, is that there is work for them to do. The bad news is they might have to change their narrative, but that's great because we get closer to the problem. And I'm saying, I think I'm discovering gravity, what the equivalent of the force that produces life, and what is the natural phenomena that does it. I haven't done it yet. I've got indications it might work. Your listeners must not take my words as proof we've made life. Most certainly not. And I didn't say that in the last episode. And had you listened to the last, Jim recounted the last episode word for word, I would explain very honestly that I am as confused as the next person. That's why I'm doing the experiment. If I already knew the answer, why would I do it? There are some people out there who are engineers doing chemistry, and because they want to make stuff and make machines and do all that. And there are other people that are going from the bottom up and saying, what is it about physical reality that gives me complexity? And that's what we're homing in on. And it's a very important problem that hasn't been addressed correctly. And I'm pretty sure we're going to be really astonished at the outcomes from what I'm seeing in my lab. But great claims need a absolutely fantastic evidence, completely transparent to argument. And that's one of the reasons why I came on and we're happy to debate with Jim, because I think this is incredibly productive to basically lay bare our assumptions and prod them and poke them and say why. And I think the prebiotic chemists are doing that now, to their credit. And I think that Jim hopefully will become more and more satisfied by that.
But Jim's earlier critique of you, Lee, that the autocatalytic kind of things that you've been able to create in the lab are at some level the very early foothills, if you like, of what it will take for more complex systems to develop and ultimately to become these, have all those facets of biological life that Jim outlined earlier. What I got from him was that is a huge extrapolation right there.
No, I can explain why in 1 second. Okay. And I think this is the thing. What we've got in our system is this. If you can imagine a system where you have a monkey on a typewriter and you say you've got a universe full of monkeys, one day they're going to make Shakespeare, you have to have a universe full of monkeys. What we've done in this system, we've shown, okay, we use pure sodium molybdate. Actually, on Earth, there is a spring in Idaho that has these molybdates, which naturally form. So we could go and find them, right, in the natural environment. These molybdates, when you add acid to them, they form a catalyst template that has information associated with it, which reads out a bigger structure that's impossible to form on its own. What does that mean? It's the template gives the monkey the information to write Shakespeare, and we get some Shakespeare out. Now, here's what I'm going to drive at. It's really important for Jim, and I hope to convince him. This Shakespeare that we've written means nothing because Shakespeare doesn't exist. So what we've got is a small template that's randomly forming, that then has that is able to template a molecule that's massive, that can't form randomly, that there is a molecular information. But now this molecule forms, this molecule can then act on itself, and that information then becomes information. So what I'm trying to say is that the act of creating information is what we're trying to capture here, and we're showing a naturalistic process. And that's why I guess Jim is uneasy, quite rightly. Like, I'm shuffling a card deck and getting a royal flush and using that royal flush to make another royal flush. And I'm excited because this is the first time outside of biology that coupled catalytic sets have been shown to emerge. People have made them in DNA and proteins, but the amount of sequence information requires you to create it. Whereas in our salt system, yes, I have to get some sodium molybdate, which is one compound, and I have to add some lemon juice to it or some acid. But then the rest goes.
I think that's why you're obviously very excited that for you this is a breakthrough, and that obviously there's a lot of work to be done in where that goes ultimately, but the principle you seem to be saying is what's there. So where do you want to begin? Take it away, Jim.
Okay, let me start by agreeing with Lee that those that are working in the origin of life community, the synthetic chemists, are amazing synthetic chemists. They've tied one hand behind their back because they restrict themselves to aqueous systems. They restrict themselves to very simple basic chemicals. They're great chemists, and they make amazingly complex things using all of their intellect, and then suggesting that this could be how life formed, which is a big extrapolation from the one little molecule that they've made. But they're great chemists. I have no problem with that. And I see that Lee is trying to get a fundamental piece of life, and that is being able to construct, to have information come from these little molybdate reactions, and that's great. I'm happy for him, and that's a wonderful thing. I still think the extrapolation is just huge, and the target is hard. Look, I don't work in the area of origin of life. This is a hard target, and what happens is, since Miller-Urey, and I've written about this, that was 67, 68 years ago, since they came up with the Miller-Urey experiment, many people thought we were very close. The problem is the target gets further away. As we understand what life is, what life as a biological life, where we live, where most origin of life people are trying to direct toward, the target moves further and further away. So we're not getting closer with time. We're getting further away with time, because every year there's more found out about a cell and how a cell communicates, how information is transferred within a cell. And you're like, whoa, this is utterly amazing. And what Lee has done is he's trying to get at the very basics of how could you get information to build up from this random system that is, he's trying to approximate randomness with a pseudo-random system in his lab and build up information. That's wonderful. Lee, I'm not contesting with you on that. I have no contest with that. But to suggest that that is a form that is going to give us some understanding of how life as we know it in a biological system, this is a very, very long way away. I don't know what that Evolution 2.0 prize demands. I don't know what its requirements are. I've tried to look it up. It seems kind of nebulous to me. But it's just so far from life. And I'm glad that Lee is here today. And he's saying that, look, we haven't made life. He thinks he's going to be able to make what have telltale signs of the beginnings of life. But I'm glad that he's admitting, maybe he's not, and he'd like to correct me on this, that he's very far from what we look at as a biological definition of life that has to have a cell, whether that be a eukaryotic cell or a bacterium. Bacterium is still a highly complex structure that we're very, very far away from that. And to project like we understand this or like we're somehow close to this is just a wrong projection.
I would directly answer that. I think thanks, Jim, for those comments. I think there's a lot we agree on. I don't think it's such a stretch, but I do understand your reservation about the comment, because I think you're correct in saying, look, the cell is so beautifully intricate, doing all these things. It has all this orchestration of all this machinery, or we call it machinery. There's stuff going on. But I would remind us, what does a cell actually do? A cell is a collection of atoms that when you feed it simpler atoms, it's able to then metabolize and work. And then what distinguishes a cell from a lump of sand and other stuff is it can copy itself. That's what fascinates us, the fact the cell is able to copy itself faithfully, not perfectly. It's not a clone. It's not like a molecular clone, like a copy of a Van Gogh, where it's slightly different and everything's in a different place. But functioning, it functions like a Van Gogh. If you see what I mean. So that's really interesting. I actually do think we might make a life form, but I think we need to set ourselves a high standard. So Jim, I would love you to be around in the next 5 years when we maybe show that we can go from a sand to a cell. We can say, hey, Jim, look, here's sand. We shake the sand in our pot and out comes a cell. And then you look at the cell and we do a Turing test and we put the cell under a microscope and you feed it food and it divides. And you look at a normal bacterial cell and it does the same thing. You're like, wow, I can't tell the difference. But you look at the chemistry in there and you see the chemistry is more primitive. Because what gives me hope is that evolution has taken a large number of years to sequence space and make enzymes and the machinery very sophisticated for the environment. But if we basically make the environment in the lab very forgiving, so we're like a nursemaid, but not a prescriber, like maybe we get in the origins of life community right now, we might see something new. So I think that's really cool. And the reason I'm excited is one reason, and one reason alone, is that for me, finding the gravity force or the phenomenon that gives life is understanding how the universe creates random objects, that these random objects can then go on and become information giving and act on random objects, because then that gives context and that creates information in the universe when there was none before. And for me, it's a natural consequence that cells will then come into being. So what I would love to show Jim in a few years is a cell with polymers in it, which are changing their sequence, producing structures of function, which help the persistence of that cell, and then show him the lineage of how that cell then emerges from a soup that has evolution occurring either at the cellular level first and then the molecular level, and you go on and make those nanomachines.
And I'm sure Jim would love you to show him that as well. I mean, my question is, Lee, do you anticipate that's what we are going to get in 5 years' time?
I would share Jim's kind of, well, let's say I'm not as pessimistic as Jim, but I'm as realistic. I don't know if it's going to work on the time scale. I'm pretty sure we're seeing that there is a phenomena, but I don't know how much time, how much stuff I'm going to need to do it. But I'm optimistic.
Be interested again in your response, Jim. And the other question that's striking me as well is, we haven't talked much about evolution in the sense what happens after the point at which you do have some kind of, because from what I hear Lee saying, he's fully confident that this process, time, and simply the ability for things to continue in an evolutionary process will develop the kind of complexity we see, as you've described in the cell, those extraordinary information processing centers that exist. And I'd just be interested in your general, as a nanotechnician, what you make of the evolutionary account in the larger scale as well as this origins of life stuff, in terms of the complexity that does ultimately come out of it. But yeah, happy for you to begin where you want to begin in terms of responding there, Jim.
Yeah, I just hope that what we will have at the end of the day is really something that does have these signs of life. So Lee has mentioned a couple of times the Turing test. Turing was very specific as to what we would need if we had a computer that is really lifelike. And so the last paper I wrote said, let's get the community together and let's define what are the targets that we would have to hit to really define that we're beginning to describe origin of life. That is a real problem here. And so if we can put some parameters on this, somebody thought that so they were explaining something and I showed them, look, I poured some olive oil in a pan and I added a drop of soap to it, and immediately that olive oil glob just started to move around. And it really looked like it was alive. It's just moving around on the surface of the water. And I told them, that is not alive. That is not alive. There are chemical effects happening. It's moving around, but it's not alive. So there are things that might look like they're living, that they're not, that there's really no life there. So if we're going to define some things and have a Turing test, let's put some parameters on it. This is what we would have to show, that this would begin to suggest a living system. But everything that Lee is talking about, everything is very far from a biological cell and the complexity of the simplest cells that we have and the simplest cells that we have signs of having. So in other words, the simplest cells that we have in the record are about the same complexity as our simplest cells today. There have been estimates that you have to have at least 256 protein coding genes and this level of sophistication. If we're going to talk about what's the origin of life, of biological systems as we look at them, Lee is going way back before this. And how much this is going to suggest about the biological systems that we see today, I don't know. But I'm fine with Lee working on what he wants to do, but let's put some parameters of what we're going to have to say that this is going to have life, because things that look like metabolism may not be metabolism. We can have lots of chemical reactions that occur and we can say, hey, that's metabolism. Or what do we mean by that? What is replication? What is self-replication? And all around this are parameters of fidelity. Does it only have to make one copy of itself and then die? And so there are parameters about this, and these things are open to discussion, so I'm open to that. Now, Lee, Justin, you talked about evolutionary things, and I think evolution is actually an argument for another day. It's not something that I've spent a lot of time addressing. I've spent short amount of time addressing. That's another problem.
Okay, we'll leave that can of worms unopened for the moment, then perhaps for another time. As it stands, Lee, I think I'm glad in a way that we've had some rapprochement between you both towards the end of today's recording, because I think you want to be modest, Lee, about what it is exactly that your research is showing. Jim is encouraging you to be as modest as possible and say, let's remember this is a long way from anything that looks like even the very simplest form of cellular life. and ultimately we don't know really what direction this might go in. Now, it strikes me though, Lee, that you're highly confident about something, which is that there's a principle at work in the universe, and it's just a case of finding that principle. It's a case of finding the natural principle of which you seem absolutely sure that complex life, humans, Bach, Beethoven, Shakespeare, are all the result of this principle simply acting throughout history, essentially. And I'm interested to know what because I think at one level it takes me back to that sort of discussion we had on the first program about this word teleology, this idea that there is a kind of a drive in the universe towards life, and not even just life, maybe conscious life, towards life that ends up understanding itself as we do. So
I don't think consciousness exists, but that's another.
Okay.
But let me answer your point. So look, in the last few weeks, we have got the beginnings of a new theory, which explains how we can measure complexity objectively in molecules. That gives us something very interesting, and I think that evolution is a phenomena that goes beyond biology. So I don't want to start the last discussion, but I would reassure James and Jim and you to say that actually the universe is evolving or uses chemistry to evolve. And that's where all that complexity comes from. Now, at the moment, I'm finishing my calculations, and I think I know how much time it can take to generate a ribosome, the minimal ribosome. Now, for your listeners, a ribosome is the minimum machine that takes genetic material and is able to produce the molecular machines of the cell and literally orchestrate the production of the cell. And many people have thought, by looking at the information content of the ribosome, that's just so high, you can't possibly arrive at it. Well, we have worked out how. Now, I'm not going to claim that we can do this in 1 day, 1 month, 1 year. All I'm going to say to you is look, I think we have a theory how, and we're going to go in the lab and do it. We should get us excited, because it starts to, again, get back to experiment, where people are saying, there's this complexity for free. How did it appear? There must be some non-natural explanation on one hand, or what Jim is rightly saying, and he doesn't want to be mischaracterized, that we just don't know how, and there could be a naturalistic one. And I'll take a nice comment that Jim made earlier, 100 years ago, we had no idea that DNA was the way that information is flowing through cells. Now we know. So I think that we are starting to do this. And I think that we will make primitive ribosomes in the lab. And I think now I have to be optimistic and modest, but there is a reason for a little bit of immodesty. And it's not about being grandiose. It's about doing something very important that chemists are not doing very well. I think we can develop a new theory which understands how biology exists, not just on Earth, but anywhere in the universe, but it's hard. I think that we need to get young people coming into chemistry and thinking big and thinking about making molecules and how molecules can make themselves, and it's hard, and we need to have a level playing field and all argue constructively so we can actually make a massive effort for humanity to understand, the same way that humanity understands that the Higgs boson exists, what principle in the universe allows life to emerge. And why I came on this program is not only that I respect Jim as a scientist, I respect the fact his right to argue, and from other people not engaging with that argument, I think is disappointing, because they need to engage with him. Because if we are going to bring young people and taxpayer money and people's time and effort from public to get enthusiastic beyond this, we need to show how we're working together. The gravity waves experiment was a 70-plus year experiment, 30 years of building, constructing, no prospect of success. And then suddenly we discovered gravity waves. And only by working together did we do it. So if part of our discussion can inspire people to work together, to reframe the problem, and to accept that we just don't know how hard or easy it's going to be, we'll get people excited. So I'm going to try. Right now I'm telling Jim, I'm going to try. I've got a method. I've got a plan. I've got a theory. I'm going to test. It could be wrong. It leads to an experiment, leads to some objective evidence, and we go attack and go around the cycle and see what happens.
Right. Jim, in some ways, Lee's almost casting it as, I'm the optimist, and and maybe you're a bit too much the pessimist when it comes to what could happen, what we might just find out in the lab about origins of life. So, I mean, you've said though clearly that you are all for what Lee is doing in trying to explore the naturalistic explanation, and presumably if he did, come up with something that met those criteria of passing some kind of a test of what life is, you would welcome it with open arms, Jim, because you want to know as well if there is a naturalistic route to forming life.
Absolutely. A naturalistic explanation doesn't bother me at all, and it doesn't upset my faith at all. I would just say, wow, God's all the more magnanimous, so that's how he did it. I mean, it wouldn't upset my faith at all. So I welcome a naturalistic explanation, and I think in life we're going to continue to see naturalistic explanations to things, and it doesn't shake my faith at all. I mean, this is why we're here.
I was going to come back to that last discussion. Lots of people think this discussion is about science and religion arguing. I would just say science and religion can exist perfectly well if one respects the other. Science is falsifiable, religion is not. And how dare I, as a scientist, say to someone who believes in something, you're not allowed to believe in that. And I think that if we respect those boundaries and that construction, we can kind of push one another. Because as I said in the last broadcast, I'm not religious, but that doesn't mean I don't think the universe is incredibly beautiful and marvelous. Now, Jim might say, oh, well, that's because you don't understand God and this is you just manifesting in a way. Might be. But as an atheist, I really exist in the universe that is my universe. And I want to ask, why do things happen? And I think that that's not anti-religion. It's not anti-belief. It also allows Jim to embrace a naturalistic explanation, because at the end of the day, if there was a Big Bang, God could just be the person that made the flick set everything up. The physicists don't have the answer for that, right?
Yeah. Do you want to respond to that, Jim, as we start to close out our program today?
Yeah, I mean, God said, "Let there be light." I mean, and there is a naturalistic explanation that then comes in. After all of this, so I think that's perfectly fine. I'm fine with naturalistic explanations, and so I've never been opposed to that, and I'm glad to see these things come forth, and I appreciate. And all
you're doing then, in a sense, Jim, is simply pointing out for people that there's still a gaping gap between the current naturalistic explanations that are being put on the table and the reality. And for you, it could well be that someone like Lee does eventually make something that's more convincing. If he doesn't, if we say we could all be sat here in 500 years' time and that target has moved even further away, in your estimation, would it raise the possibility that, well, maybe it's not a naturalistic explanation? Maybe there is a design somewhere here. Maybe someone has been prodding the bits into place that were needed for life to get going on Earth.
No, I don't think that you could ever make that jump. I don't think that that's possible. I mean, just because we don't come out in 500 years, maybe it'll come out in 600 years. I mean, so that's why I never use this God of the gap argument, that what we don't know must somehow be God, because I get surprised all the time. Every time I read the literature, I get surprised. I'm like, whoa, that's interesting. I didn't know that. So I'm quite open to naturalistic explanations, because God has set up a natural world, and that there's a naturalistic explanation for everything that we see. I'm fine with that. I'm absolutely fine with that. So anyway, I appreciate Lee joining me on this show. This is a first that an Origin of Life researcher is willing to sit down and talk with me about something.
Well, I appreciate you doing that as well, Lee. So thank you very much for coming back on the show. I should point people to both your websites, croninlab.com, find out more about Lee's research, and drjamestour.com for more about Jim's work and his speaking and so on. In the meantime, I'm sorry the time is over so quickly. I've had a fascinating and fun time myself, though. So thank you, Lee, and thank you, Jim, for being on the show today.
Thank you.
Well, so what did you think of the James Tour and Lee Cronin debate?
Well, I loved it because at the beginning, they were almost speaking two different languages, and they were on two different pages. But by the end, they were much more on the same page. Now, I don't want to overstate that, because I think Jim Tour would say that there are a whole bunch of issues that aren't even close to being addressed yet. but I do think Lee would agree that there's a bunch of issues that they haven't addressed. What I liked was several things. I liked the fact that, first of all, somebody from the Origin of Life community who Jim Tour has been criticizing actually stepped forward and was willing to publicly debate this, because that hadn't happened before. Jim had a lot of private conversations, but no public conversations. So that's the first thing. The second thing was, Lee and Jim and I all have something very interesting in common. And that is that we all really believe that science should aspire to a naturalistic explanation for where life came from. Neither Jim nor I is fond of God of the gaps explanations. Now, look, let's be honest. It's possible that life is a divine miracle. I mean, maybe that's true. Depending on how you look at it, it kind of looks that way. Nevertheless, like a scientist can't publish a paper or do research based on that. Like all scientists can do is peel the onion another layer and another layer. And we're all three in agreement on that. And I was also very happy about the fact that it created some civilized dialogue. And that is one of the major goals of Evolution 2.0, is to create civilized dialogue. And if we can get more and more factions around the design and evolution debate to sit down at the table and talk with each other sensibly and patiently the way Jim and Lee did, I think all of us are going to be much better off.
Wow.
Until next time, this is the Evolution 2.0 podcast, bridging science, technology, business, and the big questions. To ensure you never miss an episode, subscribe on iTunes or on your preferred player. If you like the show, rate us on iTunes. Join our email list and social media at cosmicfingerprints.com.